chapter 5.2. We're going to continue with probabilities, but now we're going to restrict our discussion to binomial probabilities. Now, here's some characteristics that I want to go over with binomial probabilities. Now, I'm going to use the event of rolling a die as my example. So up here I have roll a die. What are my possible outcomes? 1, 2, 3, 4, 5, 6. Okay, so a binomial experiment, there are only 2 outcomes. Now when you look at this, you go, well, wait a minute, there's 6 possible outcomes. Well, what we're going to do is define what we call success and failure. So success is going to be rolling a 5. So success, there's only 1 in there that would be considered success. Failure would be everything else. So there would be 5 that would be not success or failure. So our 2 outcomes are success and failure, and we will be defining what success and failure is. Then we'll look at and have to either be able to calculate, or sometimes it will already be given, and that is the probability of success, which we call lowercase p. So what this is talking about is on an individual trial. So if you pick up a die and you roll it, what is the probability you get success? What is the probability you roll a 5? Well, there is 1, 5, 6 sides. So the probability of success is 1/6. Then we look at what is called the probability of failure, which is known as Q. So we will define what Q is. Now, Q is basically not success, which means these are complements. Well, failure is anything that is not a 5. Well, there are 5 sides that are not a 5, so 5/6. Now, these being complements, they should add up to 1. And 1/6 plus 5/6 is 1. And that's written right here. P plus Q equals 1. Now, one thing that we also do with a binomial probability that we have not done yet, and that is define N and R. N is the number of trials. So the example of that would be if N is equal to 10, that means you're going to roll the die 10 times. R is the number of successes. Now remember, we define success as being the number 5. So if I put R equals 3, what that means is when I roll the die 10 times, what is the probability that the 5 shows up 3 times? So 5 is success, 3 is getting 3 successes or rolling 3 5s. Now, what we're going to then be looking at is how to find that probability. Now, in finding the probability of your successes, there's 2 ways. One is by using the formula, and I have that written up here, and one is by using the binomial table. Now, let's look at the formula. Here the formula is given, so I have the probability that we have 3 successes, so I put R equals 3, and I put my numbers in the formula. N is 10, R is 3, so I put it into the formula. Now, I'm not going to spend a lot of time showing you how to put this into your calculator because we are not going to be actually using the calculator. I'm going to tell you what the answer to this is in the calculator. It's 0.155045336. Again, if you can't figure out how to put that in your calculator, please don't stress, because what we're going to be using is the binomial table. So the binomial table is in your appendix. All right, so it is table 2. Now, I have yours in your book is horizontal. It's landscape. I have a table that is vertical. So it's basically the same thing. It's just on the paper different. So, or maybe it's table 3. It's table 2 or 3. Okay, so just look for where it says binomial probability. Now, if you'll notice, here's P. P is your probability of success, and over here is N. N is the number of trials, so we're going to roll the die 10 times. So let me find where N equals 10. Here is N equals 10, and then all of these numbers, 0 through 10, could be your R. So this would be 0 successes, 1 success, 2 successes, and we were interested in 3 successes, okay? Now, P for our case was 1/6. Well, if I go to my calculator and I do 1 divided by 6, I get 0.16666, which is not up here, okay? But 0.1 6 is between 0.15 and 0.2. Now, all examples you will be doing, the P will be available up here. But it's between 0.15 and 0.2. So I'm going to travel down to where we had 10 trials and 3 successes. So our calculation from the formula should be a number between 0.13 and 0.201, and we got 0.155, I think. So we're good on that. So that's where the location would be. Now, let's look at some examples that will fit on the table. Now, what I have found with most students is a lot of their difficulty comes in defining what the trial is. So we're going to spend some time doing that and showing that before we actually do the calculations. It says a genetic trait in one family occurs 25% of the offspring. If 8 offspring are randomly selected, find the probability the trait is manifested in exactly 3 cases. Okay, so the trial that we're looking at, what we are observing is the offspring in this family. So what makes it up a trial? Having a baby or the offspring. Now, what they are defining, before I do that, how many offspring are we observing? We're observing 8. So N will be 8. Now, in here it says that a genetic trait in one family occurs 25% of the offspring. So success is when that genetic trait shows up. That occurs 25% of the time, or 0.25. So on the table, that's what we will look for P. Failure is that the trait is not there. Well, P and Q have to add up to 1, so 1 minus 0.25 is 0.75. So now I have everything defined so I can use my table, because what it is asking me to find is that find the probability that it is manifested in exactly 3 cases. So we're going to find the probability that there are 3 successes, so R equals 3. So all I have to do is go to the table. I'm going to go to N equals 8, because that's the number of offspring. So here is N is 8, and we're looking for 3 successes and oops, you can't see that very well, can you? Sorry. 0.25 is what P is, so I'm going to travel down to where those meet, and they meet at, I'm just going to go ahead and circle it, because there's 0.25 and there's 3. So 0.208 is my answer. So there is basically close to 21% of the chance that of the next 8 babies, 3 of them will have this genetic trait. All right, we're going to do a few more examples that can be found in the book. So I'm going to be referring to a particular page and problem in the book. So page 206, number 15, it reads, a fair quarter is flipped 3 times. So what is the trial? Each flip of the coin. How many coins are they flipping? 3. So that's where we came up with the trial and how many coins we're flipping. Then it says, find the probability of getting exactly 3 heads. All right, so since it wants us to find the probability of getting 3 heads, I've defined success as heads, which means failure as tails. Now, in the last example, they told us 25% of the time that trait showed up. Nowhere in here does it tell me. Well, that tells me that when I flip a coin, what's the probability of getting heads? 1 out of 2, so 1/2. So the probability of getting tails is 1/2 because those have to equal 1. So then part A says that exactly 3 had tail, or I'm sorry, 3 were heads. Let me read it again. Let me open my book. It says find the probability of getting exactly 3 heads. So that's why I defined R as 3, because we want 3 successes. So I'm going to go to my table. N is 3. So here's where N is 3. I want 3 successes. And P is 0.5. So come over here to where 0.5 is, and it's this column right here. See, here's 3. There would be 0 heads, 1 head, 2 head, 3 heads, so 0.125. That is the probability of when you when you flip a coin that it's going to come up heads, heads, heads. Then it says, what is the probability? In part B, find the probability of getting exactly 2 heads. Well, it's still 0.5 is P. N is still 3, but now I want 2 heads, so it'd be 0.375. Now, part C reads, find the probability of getting 2 or more heads. So greater than or equal to 2, 2 or more would be the probability that R is 2 heads or R is 3 heads. So I'm just going to add those 2 that we already found. So it would be 0.375 plus 0.125, which equals 0.5. Now, the last one, part D, reads, find the probability of getting exactly 3 tails. And you need to be careful here because you see the number 3, so our natural reaction is maybe to say R equals 3. But we have defined success as heads. So if you get 3 tails, that means you got 0 heads. So that's why R is equal to 0. So again, P is still 0.5, and 3 times we flip the coin, 0 heads is 0.125. All right, let's look at number 16 from the book. Richard has just been given a 10-question multiple choice quiz. So what makes up a trial? Each question. How many questions are there? 10 questions. Each question has 5 answers, of which only 1 is correct. All right, so success is a correct answer. So there's 5 possible. So let's say A, B, C, D, or E. Okay, and only 1 of those is correct, so only 1 of the 5 possible answers is correct, so that's where I get 1/5 or 0.2. So failure is a wrong answer, and there's 4 of the 5 that are wrong, so 4/5, which is 0.8, and again, these are complements, so those add up to 1. So then part A says, what is the probability that he will answer all questions correctly? Well, all questions correctly would mean all 10 of them are correct. So N is 10, R is 10, and we want P of 0.2. So let's see, 0.2 is the 1, 2, 3, 4, 5th column over. Okay, so here's 10 question, 10 of them correct. 1, 2, 3, 4, wait, 1, 2, 3, 4, the 5th column, 0.000. So basically, because if you'll notice, the problem goes on to read that Richard hasn't been in class and he's just guessing. So the chance from not being to class and just guessing, the chance of him getting 100 or all 10 of them correct is basically no chance of doing that at all. Part B reads, what is the probability he will answer all questions incorrectly? Well, if he gets them all incorrect, that means he did not get any correct, so that would be 0. So we have 10 questions, 0 of them correct, and I want to go over 1, 2, 3, 4, the 5th column, so 0.107. So with guessing, he has a better chance of getting a 0 than he does 100. Now, there's some additional questions on that, but I'm not going to do every one of those problems because what I mainly want to make sure is that you can set up the problem, that you can define what a trial is, and that you can define what N and R are. So let's look at number 20 as the last example that we're going to do on this page. It's page 207. It says a research team at Cornell University conducted a study showing that approximately 10% of all businessmen who wear ties wear them so tightly they can actually reduce blood flow to the brain. At a board meeting of 20 businessmen, all of whom wear ties, what is the probability that? Okay, so what makes up a trial? Each businessman. There are 20 of them. Now, I'm going to read part A to decide what is defined as success, and it's asking for the probability that at least one tie is too tight. So I'm going to define success as too tight, and early in the problem it said that happened 10% of the time. So P is 10% or 0.1. So failure would be not too tight, and since these have to add up to 1, then I know this is 0.9, which makes that fairly easy to find. All right, so now we're going to go and read the problems, and again, N is 20 and P is 0.1. So part A reads, what is the probability that at least one tie is too tight? Okay, at least one. Well, at least one would mean 1 or 2 or 3 or 4 or 5. So that would be R is greater than or equal to 1. So you would have to find the probability of 1 plus the probability of 2 plus the probability of 3 all the way up to the probability of 20. And you can add all of those up and that's fine. Or you can recognize that it is all of them but the probability of 0. So the easier way to do this is to take 1 minus the probability of 0. So 1 minus, so I'm going to go to my table and I'm going to go to N is 20. Now, P is 0.1. Now be careful, 0.1, not 0.01. So it's the third row over, or third column over. So here is where N is 20. And I want 0, the third one over, so 0.122. So if I do 1 minus 0.122, I get 0.878. All right, part B. What is the probability that more than 2 ties are too tight? All right, more than 2. So it can't be 2, it has to be more than. So that would be the probability of 3 or 4 or 5 or 6, all the way up to 20. So one way to do it is on the 20, more than 2 would be 3, is to add 0.190, 0.09, add all of those up. And if you'll see, you get down here that it becomes 0, so you in essence really aren't adding that many. Or you could do 1 minus 0 minus the probability of 1, because greater than 2 would be 3 and above. So we could also do it this way. So 0 we found to be 0.122 minus probability of 1 success is 0.270. And the next one would be 0.285. And again, all of those numbers are found on the table. So be sure you can read the table. Be sure and email me if you have any questions on the table. So if you do that calculation, you get 0.323. Now again, there's more of those problems, but just email me if you have any questions. I mainly want to make sure that you can get this part set up and you know how to use the table. That completes 5.2.